Hi guys, today we will learn about the introduction to biostatistics, which is the basic for the research. So the definition of terms and concepts, what we have to consider here is this one. Statistics is the field of study concerned with data collection, organization, summarization, and drawing inferences about a body of data when only part of the data is observed. In this case, we are talking about statistics. We are talking about statistics because we are taking some part of the population as we take some part of the data. Therefore, in this time, we can talk about the making inference or making conclusion from the part of the data to the rest of the population. So statistical principles provide an orderly and objective approach to collecting and interpreting research data. Therefore, while we work or while we conduct a research, we have to follow this old definition of statistics. That is, from starting from the stating the problem up to the data collection, data organization, data summarization, drawing inferences about the data when we take only part of the data. Or if we take the without any systematic sampling method, if we take the whole population, we need not to make any inference or any conclusion. Okay, in nearly all areas of research, the proper use of statistics is crucial to the validity of the conclusion. Okay, therefore, if we don't know what statistics is, what are the statistical methods, or what type of subjects we are taking into consideration, we may not get the valid or we may not answer the valid research question. So the field of statistics has two main areas, that's mathematical statistics and applied statistics. In mathematical statistics, it simply looks on the development of the new methods in statistical inference. Therefore, the second one is the one that we should focus on, that is involving applying the methods or the available statistical methods or mathematical statistics to specific areas such as economics, psychology, public health, medicine, and agriculture, and so on. Okay? Therefore, the application of statistics is almost to all fields available on the earth. Therefore, the two of statistics are employed in many fields: medicine, business, education, psychology, economics, or any. So what is biostatistics? Biostatistics is simply the branch of applied statistics that applies statistical methods to medical and biological problems. In this case, statistics will have different names in different fields. For example, if you talk on economics or in economics, the application of statistics in economics, it is called econometrics. When you go to psychology, it is called psychometrics, and in agriculture, it is called biometrics, and so on. Therefore, it has different names. When we come to the biological and medical sciences, that's the biostatistics, but the steps remain the same. That is, statistics is on or statistics deals on data collection, data analysis, that is including data organization, data summarization, data analysis, making inference, and so on. So it is the application of statistical method to biological and life science concerned with interpretation of biological data and communication of information derived from the data. Hence, central role it is a central role in medical investigation. So the types of statistics, we have two broad or two categories of statistics, that is descriptive statistics and inferential statistics. When we conduct any research, we will have two categories of statistics. That is the descriptive statistics, which includes organizing and summarizing the data, and it helps us to identify the general feature and trends in a set of data and extracting useful information in it, because we may also we may clear or we may clean our data. In this case, we may have unexpected values, and we have to trace back about the study subjects under which the outlier or any unexpected value contained. So utilize numerical and graphical methods to look for patterns in the data set. Okay, example, tables, graphs, and summary measures. For example, the so-called mean, the median, mode, and so on. So what about the inferential statistics? The inferential statistics is a technique by which inferences are drawn for population parameters from the sample statistic. Therefore, sample statistic observed are inferred to the corresponding population parameters. Methods used for drawing conclusions about the population based on the information obtained from the sample of observation drawn from the population. Example, principles of probability we will apply here. The principles of probability, estimation, confidence interval, comparison of two or more means or proportions, and hypothesis testing, etc. In this in this a little bit advanced parts of the course, we will see later after identifying the primary or the basic definition of the course. Okay. So some basic terms. What is variable? In our case, variable is very important characteristics. That is a variable that we are going to code into the software and make a data. Therefore, variable is nothing but it is simply a characteristic which makes data an aggregate form of itself. That's an aggregate form of a data, an aggregate form of a variable become a data. So the characteristics or properties that changes or varies over time and or different individuals or different under consideration. A quality or quantity that may be qualitative or quantitative. Okay, it can also be defined as a generic characteristics being measured on observed, example, HIV status, heart rate, height of adult male, the weight of preschool children, the area of patients seen in dental clinic, the ages of patients seen in a dental clinic, and its are examples of variables. You can also call any variables, or you can also list any variables in your field of interest, because as we have said, statistics has many or has application in all areas or in all fields. So experimental unit, measurement, data. Therefore, the experiment unit is simply the person, the thing, transaction, event, or upon which we are collecting the data. Maybe patients in our case. So maybe buildings in the engineering case, if they are going to study the reliability theory. So the individual object on which variable is measured. Therefore, measurement results when a variable is actually measured on an experimental unit, or it may be observed. Okay, observational measurement maybe. So data, the raw material for statistics is data. Data may be defined as a value or observation resulting from process counting for taking a measurement, or in general, we can define a data as an aggregate form of a variable. A set of related observation measurements or facts collected to draw conclusions. It can also be either sample or population. For example, when hospital administrator counts the number of patients, when a nurse weighs a patient, when a researcher asks patients for their smoking status, and so on. So these are simply samples of variables. The time until light bulb burns out, then experimental unit, light bulb, then typical measurements, and so on. So you can see univariate data, bivariate data. Therefore, if a variable has only one variable, if bivariable. Okay. So there are types of variables which are very important to encode our data into any software. Therefore, these are the qualitative and quantitative variables. Quantitative can also be furtherly classified as discrete and continuous. Okay. So categorical variables are either nominal or unordered, or sometimes quantitative and discrete variables. Okay. So continuous. So this is the discrete variable and the continuous variable. So we can see the summary of this one. Okay. This is a summary: nominal variable, ordinal variable, interval variable. Therefore, this one is not important in this case because SPSS do not know this one. Therefore, these are the three measures in which are available in SPSS. Therefore, nominal variable are used name or labeled. Then ordinal scales are ordered, and ratio scale gives absolute measurement. Therefore, this is all about the introduction to biostatistics. You can now